Hey there, we're going to talk about Pascal's law right now. And here's what Pascal's law is going to allow us to do eventually. Take a look at what I've got here. I've got a syringe filled with water. There's water in here, and there's water in this tube. It goes all the way around. And watch what I can do. If I take this syringe right here, and I push on it, I push down on the small one. Look what happens to the, actually let me take this off to the side so you can see it better. I'm going to push this one down, and you see the big one goes up a little bit. And now watch what happens when I push the big one down. Watch what happens to the little one. Look at it go up. That's cool. Now this is a hydraulic system, and that's what we're studying right now. But in order to understand how this works, we need to understand Pascal's law. So that's what we're going to cover today, Pascal's law. Now, first we need to talk about pressure. And pressure is a force spread out over an area. Okay, so I mean, if I took this pencil and pressed on it with 5 pounds of force into my hand, well, that's going to hurt, because that 5 pounds of force is spread out over a very tiny amount of area. And so that's very high pressure, and that pressure would be enough to tear through my skin, and I would drive this pencil all the way through my hand, which I don't want to do. But if I took 5 pounds of pressure and I spread it out over an area, like the area of my fist right here, well, that's no problem. I can do that. So if a force is spread out over an area, well, we call that pressure. So we're going to use the capital letter P for pressure. Oops, pressure is equal to force per unit area. And so we're going to say that pressure equals force divided by area. Now, we can make one of those fancy little triangles out of it. So force, pressure, area. So if I want to know the pressure, it's force divided by area. If I want to solve this for the force, I would multiply both sides by area. So force equals pressure times area, and you get that with the triangle. You cover up the force and you get pressure times area. And then, of course, if you want to solve for the area, if you know the pressure and the force, you cover up the area, and it's force divided by pressure. Force divided by pressure is equal to the area. So these are the equations we're going to use to solve pressure problems. Now let's talk about units for a minute. There are two kinds of units that we're going to talk about in here for pressure. The metric system has a unit of pressure called the Pascal, and it's this. If I took a square meter, so here's 1 meter by 1 meter, and I press down on it with only 1 Newton of force, well, that's very, very low pressure. That's about the pressure of this piece of paper on my hand right now. It's a very, very tiny unit of pressure. And so the unit of pressure for this, well, remember, it's force divided by area, but for units, this would be a Newton of force spread out over a square meter. And this is called a Pascal, and we abbreviate it with a PA. Now, we're really not going to use this unit of pressure very much today. A more common unit of pressure is when I take a square inch. Maybe I can actually draw it to scale here. Here's a square inch, and I press on it with a force that's equal to 1 pound. So this is 1 inch by 1 inch. Okay, about like this. And if you spread a pound of force over that much area, you have units of pressure that are pounds per inches squared, 1 pound per square inch. And we abbreviate that with a PSI, pound per square inch. And this is a very common unit of pressure that we use in our system. I'd like you to actually think about this, though. I mean, what is the relationship between a pound per square inch and a Pascal? I mean, what's the unit conversion for that? So I'd like you to do that right now. Let's figure that out. I have some problems prepared here for you. And the first one is I want you to convert, if I have 1 pound per square inch, how many pascals is that? So let's set it up. 1 pound per inch squared. Okay, now what I want you to do is convert this to newtons per meter or pascals and figure out the value of that. And you can use 1 pound is 4.45 newtons and 1 inch is equal to 0.0254 meters, or 1 inch is 2.54 centimeters, and I just converted that to meters. So what I'd like you to do is use these unit conversions with this and change it to pascals. Please do that now. Pause the video and do the problem now. Okay, I hope you were successful. Let's see. We want to get rid of pounds and end up with newtons. So I go 1 pound is equal to 4.45 newtons. And that means that the pounds cancel. And now I've got newtons per square inch. And I want to go from square inches to square meters. Well, 1 inch squared is equal to 0.0254 meters squared. And when you square a small number like this, you get a really small number. And when you divide by a really small number, you're going to get a really big answer. So let's see what it is. Let's get our calculator out. And let's see. We have 1 times 4.45 times 1 is 4.45. And we're going to divide that by 0.0254 squared. And you get an answer of, wow, 6,898 pascals. So 1 pound per square inch, which really isn't that much pressure, is a lot of pascals, or a lot of newtons per square meter. Notice that we have the square inches here, cancels the square inches there, so I have newtons per square meter. So what is a pound per square inch? Well, you just kind of push on your hand gently like this. That's about a pound per square inch. And so this is 6,894 newtons per square meter, this much pressure. So it's Pascal's pretty small. In fact, for most day-to-day things, we would say that this is let's just round that off to 6.9 kilopascals. So kilopascals are more commonly used for everyday kinds of pressure. And you might see this on a bicycle pump or something like that. But here in America, we mainly use pounds per square inch. Okay, so let's move along here. And we're going to apply, solve a pressure problem now, where I want to, before we get to that, a lot of the times what we're going to be using are these, we're going to use pistons a lot. Now this is just a syringe, but in industrial purposes they have cylinders that are much bigger than this. Sometimes they're actually smaller, it depends on what you're doing. But where we're going to compress, or a fluid of some kind, either a gas, like this is just air, or a liquid. And so what we need to know is how much area is in this syringe. What's the area of that? Well, that's the area of a circle, right? So let's review what the area of a circle is. If you have, so area of a circle, well, here's a circle, and what if I know the radius of the circle? Well, the area is equal to pi times the radius squared, pi r squared. Okay, and but sometimes we don't give you the radius, we give you the diameter. Let's say here's another circle, and what if I say the diameter? The radius is from the center to the outside of a circle, but the diameter is the maximum distance from one side of a circle to the exact opposite side. And so this is the diameter. Usually we use the letter D for the diameter. And the formula for that, well, area is equal to, well, think about this, that isn't the diameter, how big is the diameter compared to the radius? Well, here's one radius, and here's another radius, so that's two radiuses or radii. So really, you could do this, you could say it's equal to pi r squared. Well, r is the diameter divided by 2. And then you got to square that. Well, that's going to be the diameter squared divided by, well, what is 2 squared? It's 4. So sometimes you'll see the area of a circle like this. Area equals pi r squared, or area equals pi times the diameter squared divided by 4. When I'm given the diameter, what I usually do is just say, okay, find the radius is equal to the diameter divided by 2, and then plug that in here. And that's what I usually do. So what I'd like you to do now is I would like you to calculate the area of these two circles. And I know this should be review for you, but you're going to be using these formulas quite a bit here in just a few minutes. So let's do that. Pause the video right now and find the area of this circle and the area of this circle. Pause it now. All right, let's see if you got them. See, the area is equal to pi times the radius squared. Well, let's just do this, 0.50 inches. Always include the units, squared. Now, what is pi? Well, if you're plugging this into a calculator, sometimes pi is on your keyboard already. And look right here is pi. So I can just do this. I can just say, I go second function pi times 0.5 squared, and I get the area as being 0.785. So let's do that. 0.785. And what are the units here? Well, what did we square? We squared inches times inches. That's square inches. So that's the area of this guy. Hope that's what you got. Now this one you can do two ways. You can take the diameter and divide it in half. Well, what's 1.5 divided by 2? It's 0.75 inches, and then you can square that and multiply it by pi. Or we can use the formula for diameters. This is pi. Now instead of, if you don't have pi on your keyboard, just go 3.14. That's good enough. And multiply it by the diameter, 1.50 inches squared, divided that by 4. Okay, and let's see what we get. Let's see, we have 3.14 times 1.5 squared, and then we're going to divide that by 4, and you get 1.77 inches squared. So that should be your answer for this one. Okay? Very good. Now you're going to use those formulas here in a minute to solve some problems. Now let's actually use the pressure formula that we came up with if I have a piston. Let's talk about what a piston is. A piston is usually circular. So here's a piston. And a piston is, sometimes it's, let's seal this one all the way up, and we're going to press on it with a force. Now this is the part of a piston that can slide up or down. So this part right here can slide up or down, and I'm going to push down on this with a force. Now this piston right here has an area to it. So to figure out the pressure that this piston places on into the fluid in here, we say the pressure is equal to the force divided by the area. And so that's what, and that's how we'll calculate it. Well, but now let's before we actually get to the calculations, this is a good time to talk about Pascal's law. Here's one of the interesting things about this fluid, is that when I compress this fluid down, the pressure is the same everywhere inside the vessel. So this is pushing out, this outward pressure is pushing up, it's pushing down. Everywhere inside this container, it feels the pressure from pushing this down. And that's called Pascal's law. And so let's work a problem now where we have to figure out what the pressure is inside a container like this, inside a piston. And so what I'd like you to do now is work this problem out. I've got a piston and I'm pushing down with 20 pounds of force, and the radius of this piston, this is a circular piston here, the radius of it is 0.5 inches. So let's figure out what is the pressure everywhere inside this vessel according to Pascal's law. So pause the video and solve that problem now. Okay, let's figure out what the pressure is. Pressure is equal to the force divided by the area. Now I know what the force is, that's given to be 20 pounds, but I don't know what the area is. But I was given the radius, and the radius is 0.5 inches. Hey, I already solved this problem. Look up here. If the radius is 0.5 inches, well then the area of that piston is 0.785 square inches. So I'll just use that. If you want to solve it separately, you certainly can do that, and that's what you'll have to do on the practice problems I'm going to give you. But this is 20 pounds divided by an area of 0.785 inches squared. So the pressure is equal to 20 divided by 0.785 square inches, and this gives us a pressure of 25.5 pounds per square inch, or PSI. And there's my answer. Okay, now we're going to get to something a little more interesting. Let's take the piston, lay it on its side, and we're going to have a piston that looks like this. Here's a circular piston, and I'm going to apply a force to it, and that's going to put pressure everywhere inside here. Okay, but now I'm going to take this and I'm going to connect this via a tube like I showed you before, and I won't make it a very long tube, and I'm going to hook it up to another piston And maybe this piston's a lot bigger. And this has got a fluid in it, and maybe this has got an area like this. So this has a force, and I'm going to call this piston 1. So this is the force I apply to piston 1, and this has an area of A1. And this is going to put a pressure on this fluid, and Pascal's law says that this pressure is everywhere the same, even inside this tube. So the pressure is everywhere pushing on the outside of this container, even over here, all the way over here. So if I press this in, the fluid is going to apply a pressure, an equal pressure over here. Now this is, here's piston 1, this is piston 2, and this is going to apply an outward force like this. Call this F2. And this has a certain area, A2. Well, here's what we're saying. The pressure in the first piston is going to be equal, according to Pascal's law, to the pressure in this piston. The pressure in 1 is equal to the pressure in 2. Well, this is going to allow us to figure out what this force is, or what this area is. This is going to set up a proportion, because we know that the pressure in piston 1 is equal to the force 1 divided by the area on 1. But this is going to be equal to, I meant to put a 2 here, I'm sorry. So the pressure in piston 1 is equal to the pressure in piston 2. And so this is going to be F2 over A2. Now, what if I knew what force I was pressing on this, and I was going to push this thing in, and it gives it a certain pressure? How much force am I going to get out of this thing given this area? And that's just what I have right here. Look, I've got 2 pistons, and I'm going to, well, let's see, let's get this ready to go. I'm going to take this smaller piston, and I'm going to push on it like this. So I'm going to have an inward force, and what I'm going to get out of it is I'm going to get a force pushing out. See that? Now the force I push in is going to increase the pressure of the fluid inside, which is just water, but that applies an equal amount of pressure in here, but the area is different here. This is a much bigger area. So what's going to happen to the force? What's going to happen to the force on here? Well, if the pressure is the same, then this is the same, and I can use this proportion. Let's solve for F2. If I want to know what F2 is, remember how to do proportions? You go, you cross multiply and divide. So F2 is equal to F1 times A2. So F1 times A2 divided by A1. Now what do you think is going to happen to F2? Well, look at area 1 is much smaller than area 2. So I get a number that's bigger than 1 here. So what's going to happen is F2 is going to be a bigger force than F1. This is kind of like a simple machine. It multiplies my force. For a little bit of force in here gets me a much bigger force over here. Well, how much bigger? Well, it depends on the ratio of the areas. If this area is 3 times the area of this, I'm going to get 3 times the force. And this is the way hydraulic systems work. You put in a smaller force here, you get a bigger force out. Of course, you do pay a price for it, right? I mean, if you push this one all the way in over here, you don't get nearly as much distance. So just like in a simple machine, if you want to multiply the force, you have to, by the same proportion, increase the distance that you push in over here. And we'll talk about that later. So let's solve a problem like this, where you have to figure out what the force is. And this will be the last problem we're going to do. So here I've got 2 syringes hooked together, and here's F1. F1 I'm going to press in with 10 pounds, And the area on this, I've already figured it out, is 2 square inches. And that's going to push in on this fluid, increase the pressure in this fluid. How much force am I going to get out of this thing? Well, here's where you always start with problems like this. Because this is a fluid, and because of Pascal's law, I can say the pressure in 1 is equal to the pressure in syringe number 2. But the pressure in 1 is F1 over A1, right? And the pressure in 2 is equal to F2 over A2. Now you solve it from here. Finish this problem, and so stop the video now and finish this problem. Okay, let's see how you did. I want F2. So F2 is equal to, well, cross multiply and divide. It's F1 times A2 divided by A1. And so F2 is equal to 10 pounds times A2. Well, A2 we said here is 8 square inches. That's given. Divided by A1, which is 2 square inches. Notice the square inches cancel. And F2, you don't need a calculator for this. What is 8 divided by 2? Is 4. 4 times 10 is 40. 40 pounds. That's my answer. So if you press in with 10 pounds over here, you're going to get 40 pounds over here. And that's how hydraulic systems work. One last thing. I'm going to talk about the difference between pneumatics and a pneumatic cylinder and a hydraulic cylinder. Here I've got 2 identical syringes. This one is full of air, and this one is full of water. Now watch what happens when I plug the end. I'm going to press down over here, and I'm going to squeeze this in, and watch what happens. I can actually squeeze the air in, and see how it pops back out? I can push that in, and then the air pushes it back out on its own. Air is compressible. I can reduce its volume, and when I increase the pressure, I reduce its volume. But look at water. If I put my finger right here, and I try to press it in, nothing's happening. It doesn't press in. Maybe a little tiny bit. If it's pressing in a little tiny bit, it's because the plastic itself is ballooning out. Water doesn't change. Water doesn't change volume when you squeeze it. It's incompressible. If you use a gas to spread pressure around, Pascal's law still works, but this is called a pneumatic system. When you use a compressible gas to spread the pressure. If you use a liquid, that's called a hydraulic system. We'll learn more about that later on. Okay, that's it. Now do the problems. That is all.